Hey all, I wanted to showcase some of the features that I've been adding to the Spine Unity workflow from the Unity side of things to speed the process along. So first and foremost, importing Spine data can now be done almost entirely with the right-click menu. So I guess we don't need these to show this off, but currently you can right-click on the JSON file that is exported from Spine, and it assumes that the texture atlases and the atlas file itself are adjacent to this file. But ingesting is as simple as right-clicking. And there you go, there's your Spine data. I've also extended Unity to have a fairly robust preview window that can preview animation as well as skin changes and gives you some variously useful information like which animations are there, how long they are, what's their frame count, and so on and so forth. I've got the Goblins examples imported as well here to show that it does properly support skin switching. And animation switching as well. It will also show where various events are in the timeline if they are on the currently playing track. There's a preview slider here for ease of use, and you can always zoom in and out to get a good look at making sure everything's actually working inside the Unity runtime. But anyway, importing information is all well and good, but there's was one big gap in the Spine Unity workflow that I found, and that was it was very hard to integrate any real code beyond playing basic animations and moving an object around inside of Unity. So I've extended a few classes, in particular the skeleton animation class and the bone component behavior, to give a little bit more integration directly into Unity. So I'm going to try and show some of that off with the Goblin demo here. So to bring the Goblin into the scene now, or bring any Spine skeleton into the scene, I've added another spawn button. So you can simply right-click on the skeleton data asset and click spawn, and that will bring in an instance of this guy. In this case, the Goblin's default skin does not have any really useful information, so I'm going to switch that over to the main Goblin skin. So at this point, you really can't do a lot with this other than queue up a basic animation before you have to start writing controllers. Turn the speed down a little bit. So I've added a class called Skeleton Utility that has all sorts of features for, at the very least, doing previs and figuring out where all the parts are. If you look at the scene view, you will see that it draws out all of the spine bones, so you can at least get a quick glimpse of what's going on inside the rig. And all of those will, of course, update during runtime as well. In the inspector, you'll find all the slots listed, and you can close those down if they get obnoxious. And also tweakable properties for each of these. So if you wanted to go in and change alpha for a specific slot, or if you had an attachment you wanted to toggle on and off, you can do that for default values for your spine sprite, all within the inspector now, instead of having to write a custom controller or browse through things. When you change skins, everything should update correctly. So in this case, it even reflects that the male Goblin skin had meshes everywhere, but the female Goblin skin has images, so the icons here reflect exactly what you would see inside Spine. So you can very quickly go back and forth and debug maybe something that went wrong in Spine, or the data that you have in Unity is not as up to date. So this gives you a very, very top-down view of what's going on without having to tear through lines of JSON or write some code analysis thing. Currently, none of the information inside of the slots menu serializes, but that's definitely coming in the near future. Okay. Switch back to the male Goblin, why not? So again, you can't do a whole lot with just the spine runtime in Unity in terms of how we're normally used to editing things inside the Unity editor, being, you know, bones and nulls and game objects you can drag around and transform. So inside of skeleton utility, I've added some features that will expose all of the bones from the spine rig as transforms in their proper hierarchy directly underneath here. And while it's doing that, it will also attach the extended bone component behavior, which will allow you to drag the bones around and rotate them, as well as follow the bones that are already there. So I'm going to click a build hierarchy button, and the first thing I'm going to do is click the follow button. So this should spawn a large hierarchy underneath your main spine sprite. And you'll see little circles have been added as icons here as well, and these are just quick click macros. These should not be movable or draggable because they aren't all respond in follow mode. This means that while the animation is playing, these will behave just as the original bone component was doing, which is just following the bone and giving something that you could parent, like a particle emitter to, or some other special effect or something like that. So I'm just going to delete all those because that's not what I want to show off. There's a few properties in here that I'll get more into later, but for now I'm actually going to turn a couple things off, including the animation, because I don't want to do that yet. So I'm going to click the both button, which exposes these new bones as having the follow transformation rotation and follow transform position. And right now their apply on update bones is checked as off because we are not currently animating the character. If you were animating the character, or the spine sprite, you would need to check this so that the changes are applied after the animation information. So now all of these should be exposed as Unity objects, and you can have at rotating them inside the editor, and these will definitely survive skeleton resets, skin changes, because they are just hierarchy items. You can serialize these to your scene, all that stuff. Kind of the way I prefer to work with this is to select the root, or the thing above the root, the actual spine sprite with the skeleton renderer or animation on it, and lock the inspector so that I can click off of it, and it will stay here in the inspector with all of its all of the slots visible, and also still draw all of the bones. You'll also notice that with this selected, it will show null bones as well, so the two pivot points that I believe are root and hip, root, hip, and whatever that other one was, pelvis, or the groin bone down there. These all behave correctly with the undo functions as well, so you can just go crazy trying to get whatever pose you want to get into this place as quickly as you can, just to get a character into position for posing or whatnot. It's worth mentioning that because these are now exposed as a hierarchical item, rather than using the skeleton animation class, you could very well use the natural Unity animator or animation class. This does not mean that it's going to import the animation data from Spine, but if you wanted to create an animation inside Unity, you could use that as is right now. There are some things that the Unity animation classes, such as and the wonderful support of mechanism and retargeting, just are not practical for dealing with within Spine. And one of those big ones is freeform mesh deform, or freeform deformation, and slot changing and skinning. They're just really hard to accomplish with integration with mechanism. So at the very least, you could get basic keyframe information in this way if you wanted to. So I'm going to delete my hierarchy once again, and this time I'm going to check apply on update bones, and I'm still going to spawn these as both. And notice they snap to the currently deformed positions correctly, so there's no hard reset here. Everything you did before is safe. And in this case, I'm going to go through and choose to unlock the inspector. I'll go back to my root again, and I'm going to queue up the walk animation. Everything should be working the same way, but if I take a bone right now, let's say the spear tip for a good example, and I uncheck apply on update bones, you'll notice that this no longer affects the mesh, and that's because the animation component is constantly refreshing, even though we're in edit time right now. And that's it. It's just the order of operations makes it a lot easier, or actually pretty much necessary, to choose apply on update bones to apply on top of a spine animation. So if I jump into play mode here, you'll notice that all the freeform deformation stuff is going on, but all of the rotation and positional information is being overwritten by the hierarchy. So to show off why this becomes really powerful, I'm going to go through and start unapplying via the follow transform alpha slider the various channels of the hierarchy. So in this case, I'm actually mixing the transforms between the hierarchical goal transform, which is all the dots on here, which we set up with the Unity hierarchy, and the spine animation information. So now we've got our walk cycle going in. We can blend this out a little bit, and there you go. So you still will have complete control over everything that's still blended in. So if you wanted to make the head look in one location, you can blend that directly on top with any standard Unity script. So you could apply a new one here that says look at target and just make sure that the bone is facing the right direction. Notice the bone direction is actually tied to the spine information. It's not always X forward or Z forward. I believe when it's imported from spine, it's always X should be the direction the bone itself is looking. So in this case, you would want to create another vector that pointed out towards his nose and then do some math on it to get it to actually look forward. But anyway, moving on. Let's see, I think we're still in the right configuration here. Yeah, so we're still applying over the animation information. And I'm also going to use child transform alpha. This is a very beta function that just grabs all the bone components and changes their alpha feature at the same time, so I can quickly blend between the transform hierarchy influence and the spine animation influence. If you've seen the other two buttons here, you're probably got a hint to show what's about to go on. I'm going to create a quad in the scene, and I'm going to give it a 2D collider, a 2D box collider down here, and just give him some ground to ragdoll himself onto in a moment. So with all of the hierarchy here, it's important to notice that the root's all the way down here, so for a ragdoll effect it doesn't make a whole lot of sense to create a ragdoll joint down here, otherwise he's going to be flailing around the pivot point down there. So really a center of gravity or a hip joint is pretty much the right place for this. So in skeleton utility, and this honestly this is again a beta location, I'm probably going to move the ragdoll functions to another script to allow further customizability and extension. And I'm going to drag the hip over here, and it's going to create a direct reference to the bone component on the hip. If there's no bone component on the object, it will ignore it and it will not work. Okay, so everything else in here is probably just the way we left it. And we should actually be good at this point to at least let it do some basic auto generation of a ragdoll mesh for this guy, or ragdoll configuration. I'm going to turn gizmos on down here just so we can see more of the colliders. And again, when you slide this forward, it does blend more towards the transform morph. So the only thing left to do here is to apply a rigid body rig to the transform hierarchy, and then we effectively get ragdolling with spine. So when I click the ragdoll button, it's going to do a whole lot of magic, and it's going to generate some basic box colliders that are the same length as the bone and spine, and with a thickness or a width that's configurable in code that I should expose as a public variable at some point. And by clicking restore, we smoothly adjust the blend slider back to 0, which restores it right back to the animation. And notice that the bones are now following, even with the rigid bodies enabled, following the original spine animation. And we can always do more with toggling the rigid bodies on and off, and the joints on and off, but it doesn't hurt too much. So switch back to ragdoll with a different effect. That was a little bouncier. Restore it again. One more time. Gizmo's off so we can see all the beauty. There we go. And again, this is all blendable, so if you had an animation that you wanted to take and detect whether or not he was face up when he was ragdolled, you can do a specific animation that kind of looks like he's getting up from on his back position, and maybe another one from the front position, and so on and so forth. And then blend between them as needed to create that really smooth interaction between the Unity physics system and the spine animations. So one of the things that's really obvious here is that there's objects here that are clipping through the floor, and box colliders are obviously not enough to cut that kind of stuff out of our scene. So one of the other elements of this is that it does check to see if there's a collider already present on an object. So in this case, here's the head. I want to add not a rigid body here, but at the very least a collider to it first. So I'm going to choose Polygon Collider and add this to his head, and then just use the standard Unity Physics 2D toolset to create some kind of a bounding mesh. At some point it might make sense to actually use the mesh information, especially because in this case the head actually has a mesh on it. You might be able to trace that and turn that into a polygonal collider, but sometimes it just makes more sense to make a lower poly count approximation of where the head should be. I think there was another case where the shield had a really big circular thing on the end of it, and I think the bones don't stick out very far, so you really want these to kind of hold over the entire thing. So I'm going to add a Physics 2D circle collider, get a bigger radius, and that should get us pretty close to where we want for that. I think the only other one from when I tried this was the other hand. Yeah, because the bottom of the spear is parented to the hand, not to the rest of the spear. It does not have its own bone, so I had to draw another collider in there to get that to behave correctly. So again, we're using standard Unity 2D physics colliders. I'm going to hit the play button, turn on gizmos just so we can see everything going on in the background. And I'm going to choose Ragdoll, and it'll blend itself into controlling against all this stuff. Let's see if we can get his head on the actual ground. Maybe not. One more. Oh, so close. But you can see that the shields with the circle collider is behaving like a circle collider, and everything's working pretty much as you would expect. The freeform deformation here probably should be blended out as well, but that's easy enough with a piece of code to turn down the alpha on everything from the skeleton animation as well. Let's see, there was one more feature I wanted to go over. I haven't integrated all of this with ragdolling just yet, but a thread on the spine forums requested something called root motion, which is a very well-used feature in Unity that everybody's kind of used to at this point. I mean, we really are pampered by the fact that Unity's just got so many built-in features like that, but root motion in particular is one of those things that it really hurts as an animator when you're trying to make something like a zombie walk, and you've got this really big like lurching, and you've got to go in and try and animate the character going forward in these bursts, and in a physics system, for example, and you can't get them to line up correctly with the animation. It just looks weird. So I added a new class called Skeleton Root Motion, which does analysis on the root object of the spine skeleton and applies it in reverse to the root object, or it nullifies the root object, and then applies the delta from the previous frame to the transform of the spine object. So what that looks like here, we've got, and as we're not in center mode, we are in local mode, so this is the actual root transform of the object moving side to side with walk, and using the root information from the spine animation file to drive as the object moves forward. I'm not sure how well you can see this on video, but it actually moves with pacing with the object, and same with run as well. So everything is, the feet are planted, there's no sliding, everything is just animated in spine, because you're not animating as if it were on a pin anymore. You're actually animating it in space inside of the spine editor. And I think I can pull open spine real quick and show that off. Yeah, sorry about that. So when I say true root motion, there we go, there's all the bones. In this case, the hip is actually the root. This is not how I would choose to animate. I would normally have a null all the way down at 0, and then use that as the root motion generator. But it works just fine because we're really only looking at the X component of whatever the root bone happens to be. So when I say root motion, I literally mean like you're analyzing the animation data from spine. So rather than animating on a pin in spine, you actually animate it as if it looks correct in here, like your character is moving through space. And you take the delta information from whatever component you want, in this case the X component, of the root bone, drag the character back to 0 at runtime, and then apply those changes to the physics object that it's parented to, or to the transform, as the case is in the demo I showed a few moments ago. It's a little more apparent with the walk animation, where you get this kind of nicely paced. He actually moves forward a little faster right as he pushes off with his foot, and that's kind of what you see in fidelity from a lot of modern 3D games that use root motion. So it would be very, very good to have that more tightly integrated with the spine at some point, but for now we can pretty much choose any node out here and choose to use that as a root motion object. Well, that's pretty much it. Thanks for listening. Talk to you soon.